Welcome to Omni, where we explore the hidden wonders of biological vision. Today, we dive into the deep, dark ocean. Beneath the waves, where sunlight barely reaches, a legendary predator rules the shadows with absolute precision and terrifying, silent grace. We are talking about the shark, the ultimate hunter of the abyss, perfectly adapted to survive in extremely harsh environments. In these murky depths, visibility is almost zero. Yet the shark navigates and hunts as if bathed in bright daylight. How do they see when there is absolutely no light? The answer lies in millions of years of evolutionary engineering. Unlike humans, sharks do not rely on bright colors or sharp details to understand their incredibly vast and complex surroundings. Instead, their eyes have evolved to become the ultimate low-light sensors, capturing the faintest glimmers in pitch-black water. The secret weapon inside a shark eye is a remarkable biological mirror called the tapetum lucidum, located behind the retina. This reflective layer acts like a natural night vision device, bouncing photons back through the photoreceptors for a second chance. By reflecting light twice, the tapetum lucidum effectively doubles the amount of visual information the shark brain can actually process. If you shine a flashlight into murky water at night, a shark eye will glow eerily because of this reflection. Cats and dogs have a similar structure, but the shark version is highly optimized for the dense scattering underwater environment. In the world of photography, pushing a camera to see in the dark requires cranking up the ISO sensitivity significantly. However, high ISO always introduces visual noise, making the image grainy, chaotic, and very difficult for the human eye to interpret. The shark visual system remarkably acts as an organic noise reduction filter, perfectly smoothing out the chaos of murky waters. Rather than getting confused by the visual noise, the shark brain focuses intensely on high-contrast shapes and moving shadows. Color vision is a luxury they simply do not need. Survival depends entirely on detecting the stark contrast of prey. A dark silhouette against the slightly lighter surface above is all the visual confirmation a hungry, great white shark requires. This incredible focus on contrast allows them to track fast-moving targets through thick underwater dust storms and oceanic gloom. But vision alone is not enough to make them the undisputed apex predators of the vast and unforgiving marine ecosystem. Sharks possess a highly sophisticated sensory network that perfectly complements their remarkable night vision during a high-speed, deadly hunt. Along their sides runs the lateral line, an extraordinary organ capable of detecting minute pressure changes in the surrounding water. When a struggling fish thrashes in the distance, it creates tiny acoustic pressure waves that travel rapidly through the ocean. The shark feels these vibrations, instantly turning its body toward the unseen prey long before its eyes confirm the target. As the predator closes the distance, its contrast-enhancing vision takes over, locking on to the distinct outline of terrified fish. This seamless integration of pressure sensing and night vision makes the shark an inescapable force in the dark oceanic depths. Human engineers and optical physicists are currently studying the shark eye to develop next-generation underwater cameras and surveillance equipment. Designing a camera that can pierce through muddy, turbulent water without relying on massive, power-hungry floodlights is massively challenging. By mimicking the tapetum lucidum, scientists hope to create synthetic lenses that naturally amplify ambient light without generating digital noise. Furthermore, software algorithms are being trained to prioritize contrast over color, just like the neural pathways of a hunting shark. These biologically inspired cameras could revolutionize deep-sea exploration, allowing submarines to navigate treacherous underwater canyons with unprecedented safety margins. They could also be deployed in disaster zones, helping rescue robots see clearly through thick smoke, dust, and muddy floodwaters. The shark reminds us that nature has already solved some of the most complex engineering problems we currently face today. Millions of years of brutal natural selection have refined their sensory organs into masterpieces of biological efficiency and deadly precision. Every time a shark strikes in the darkness, it demonstrates the incredible power of evolutionary adaptation in extremely harsh conditions. Let us delve deeper into the specific mechanics of how light behaves when it enters the dense medium of saltwater. Water absorbs light rapidly, stripping away the red and yellow spectrums first, leaving only a monochromatic, dim blue-green world. The shark retina is densely packed with rod cells, the specific photoreceptors responsible for detecting light intensity rather than color. This overwhelming concentration of rod cells maximizes their ability to perceive the faintest gradients of light in the surrounding gloom. While we humans struggle to see our own hands in deep water, the shark perceives a landscape rich in textures. Some shark species that live in the absolute deepest parts of the ocean have eyes that make up half their head. These giant ocular orbs act like massive satellite dishes, capturing whatever stray photons manage to drift down from the surface. It is a world where every single particle of light is precious, and wasting even one could mean absolute starvation. The pupil of a shark can dilate and constrict, much like ours, adjusting dynamically to the shifting underwater lighting conditions. In shallower waters during the day, the pupil shrinks to a narrow slit to protect the highly sensitive retina inside. But as the sun sets and darkness falls, the pupil expands enormously, opening wide to drink in the available starlight. This dynamic range is something modern digital sensors still struggle to achieve without losing critical details in shadows or highlights. Imagine a security camera that could instantly adjust from staring at the blazing sun to peering into a pitch-black alleyway. That is exactly what the shark eye does, naturally, seamlessly transitioning between vastly different lighting environments without any noticeable lag. The biological hardware is impressive, but the software running in the shark brain is equally crucial for its hunting success. The optic nerve transmits massive amounts of raw visual data to the brain, which must instantly filter out useless information. This rapid processing speed allows the shark to react in milliseconds, striking its prey before the victim even senses danger. When the water gets incredibly cloudy due to storms or churning currents, the visual noise increases dramatically for any observer. Particles of sand and organic matter scatter the light, creating a blinding fog that disorients most marine creatures almost instantly. Yet the shark remains completely unfazed, relying on its advanced neural filtering to isolate the solid shape of its target. It is the ultimate lesson in signal-to-noise ratio, a concept fundamental to biological perception and electronic communication systems. The shark brain suppresses the static of the swirling sand, enhancing the subtle outline of a fish hiding nearby perfectly. Engineers are striving to replicate this exact neural filtering process using advanced artificial intelligence and complex machine learning visual algorithms. By feeding computers thousands of images of murky underwater scenes, they teach the artificial intelligence to recognize shapes despite distortion. This technology will eventually allow autonomous underwater vehicles to navigate coral reefs and shipwrecks without human intervention or bright lights. The military is also deeply interested in these biologically inspired visual systems for covert underwater operations and submarine threat detection. A sensor that can see through the dark ocean without emitting its own light is a massive tactical advantage underwater. It allows submarines to remain completely undetected while maintaining a clear view of the surrounding aquatic battlefield and potential enemies. But beyond military and industrial applications, studying shark vision helps us appreciate the sheer brilliance of the natural marine world. These creatures have been swimming in our oceans for over 400 million years, surviving multiple mass extinction events easily. Their incredible longevity is a testament to the perfection of their evolutionary design, particularly their highly advanced sensory perception systems. They are not mindless eating machines, but highly sophisticated sensory platforms, perfectly tuned to the specific frequencies of their environment. Let us take a closer look at the lateral line system, the physical counterpart to their incredible night visual capabilities. This network of fluid-filled canals runs just beneath the shark skin, from its snout all the way to its tail. Inside these canals are tiny hair cells, similar to the ones found inside the human inner ear for detecting sound. When water gets displaced by a moving object, it flows into the pores of the lateral line, bending these hairs. This bending triggers nerve impulses that tell the shark exactly where the movement originated, its speed, and its overall size. It is essentially a hydrodynamic radar system, allowing the shark to map its surroundings in 3 dimensions without using eyes. When combined with their night vision, the shark possesses a redundant, fail-safe tracking system that is virtually impossible to evade. If the water is too dark for the eyes, the lateral line guides the way toward the struggling, unaware prey. If the water is too turbulent for the lateral line, the tapetum lucidum catches the faint silhouette of the target. This dual sensor approach ensures that the shark rarely misses a meal, regardless of how hostile or chaotic the environment becomes. As we continue to pollute and alter our oceans, the water clarity in many coastal regions is unfortunately decreasing rapidly. Algal blooms and sediment runoff are making the shallow seas murkier, presenting new challenges for many marine species living there. Yet sharks are uniquely equipped to handle these changing conditions, thanks to their millions of years of rigorous evolutionary training. While other predators may struggle to find food in expanding dead zones, the The shark contrast vision remains highly effective, always. They are the ultimate survivors, adapting to the darkness both literally and metaphorically, as the planet oceans undergo massive transformations. We have much to learn from these ancient mariners, not just in terms of engineering, but in resilience and adaptability. The optical principles governing their eyes are universal, applying equally to the depths of the sea and the vast cosmos. Astronomers use similar techniques to filter out cosmic noise when photographing distant galaxies hidden behind massive clouds of interstellar dust. Enhancing contrast and gathering every available photon is the absolute key to unlocking the deepest secrets of ocean and space. The shark eye is a living telescope peering into the inner space of our planet with unmatched clarity and focus. As we build better cameras, we are essentially trying to replicate the biological perfection that nature achieved long before us. Our silicon sensors and glass lenses are still playing catch-up to the organic brilliance of the tapetum lucidum retina. Perhaps one day we will create a mechanical camera that can truly see the world exactly as a great white does. Until then, we can only marvel at the sophisticated engineering hidden behind the cold, black eyes of this apex predator. The next time you look at a photograph taken in low light, think about the noise and the lost details. Remember that somewhere in the deep ocean, a shark is navigating through absolute darkness with a perfectly clear, noiseless view. It is a humbling reminder that human technology, despite all its rapid advancements, is still just imitating the natural world. Omni Eyes will continue to explore these fascinating intersections between biology, technology, and the hidden wonders of the visual spectrum. We are dedicated to uncovering the secrets of sight, from the smallest insects to the largest predators of the deep. The ocean remains one of the final frontiers on Earth, holding countless mysteries waiting to be revealed by curious minds. Through the lens of science and biomimicry, we can illuminate the darkness and understand the creatures that call it home. The shark vision is just one chapter in the incredible story of how life adapts to the most extreme environments. As our journey into the dark depths concludes, we leave with a profound respect for these ultimate masters of abyss. Their ability to find light in the darkness is a powerful metaphor for scientific discovery and human innovation moving forward. Keep questioning what you see, because there is always more to the picture than what meets the naked human eye. Thank you for joining us on this deep dive into the extraordinary visual world of the ocean's most feared hunter. We hope this episode has changed your perspective on sharks and the incredible biological technology they carry within their eyes. This has been Omni Eyes, bringing the unseen world into focus. Subscribe for more optical adventures, and see you soon.